So this is the first problem of today's Codechef Starters, and in this problem we are given that a palindromic prime number is basically a prime number which is palindrome, and we have to find, given an integer n, we have to consider the first n palindromic prime numbers, and we have to find how many of them have an even number of digits and how many of them have an odd number of digits. So first of all, if I look at these are the palindromic prime numbers, right? So if we look at this, so I have written some of them here. So 101 and then 131. So 101 and then 131. So basically this thing. So these are palindromic prime numbers up till 131. So how to, our task is, given a value n, we have to find up till n, or basically looking at the first n palindromic prime numbers, how many of them will be having even number of digits and how many will be having odd number of digits, right? So my claim is that only 11 is a palindromic prime number, which is having even number of digits. Now let me explain why. See, what is the proof of this? The proof of this is, forget about primes for a moment. Let's look at only palindrome. A palindrome number which is even will be something like this, right? These two will be equal. These two will be equal. And these two will be equal. Yes, no, right? Now, if this is the first digit, this is the second digit, third digit, fourth digit, fifth digit, sixth digit. Now, first digit is equals to sixth digit, second digit is equals to fifth, and the third digit is equals to the fourth digit. Now, can I not, using this thing, these two are equal, these two are same, these digits. So can I not write this like the sum of digits at 1 plus, if I take 3 and then I take 5, this will be same as 2 plus 4 plus 6. These two will be equal. Why? Because 1 and 6 are same, 2 and 5 are same, 3 and 4 are same. So this thing is valid, right? For a number which is a palindrome and which is a 6-digit number, this thing will be true. The digits, this is not 1, this is the digit at 1, the sum of that digit plus the digit at 3 plus the digit at 5 will be same as the sum of digits as 2, 4 and 6, right? Yes, no? Okay. Now, what, the divisibility by 11, all the numbers which have the sum of their even digits equals to the sum of their odd digits, the digits which are at odd place. Basically, this is the divisibility of 11. All the numbers which have the sum of digits at odd indices or positions equals to the sum of digits at even places are divisible by 11. So this means that all our palindromes of even length will be divisible by 11, right? This implies this thing. All our palindromes of even length will be divisible by 11. So if they are already divisible by 11, how can they be palindromes? So the only number which is palindrome is 11. 11 is divisible by 1 and 11 itself. Now all the numbers after this which are even length and palindrome will be divisible by 11. So they won't be palindrome anymore. So palindrome primes of even length don't exist other than 11 itself. Is it clear now? What is the proof? First of all, I wrote this a 6, that is even digit number. Then since these have to be equal, I can write this thing. So what is this? This simply means that the sum of odd position digits is same as the sum of digits at even places. So, but this is nothing but this is the divisibility of 11. So that's why we don't have any other prime palindromes of even length other than 11. So that's why our answer will be simply if our n is more than or equals to 5. Why more than equals to 5? Because the fifth prime palindrome is 11. So if this is more than equals to 5, then our answer is there is one even and n minus 1 odd. Otherwise, our answer is 0 and n. I hope this is clear. I'll show you the implementation quickly. So here, this is the implementation. If n is more than equals to 5, then the output will be 1 and n minus 1. Otherwise, the output will be 0 and n. So now going to the next problem. So in this problem, we are given that the island of TLE is divided into n distinct territories, followed ruled by several different clans, and each having an unique integer between 1 and n assigned to it. Now the islands can be considered a linear space with the ith territory located next to I plus 1th 1. So the ith territory is initially ruled by clan AI, and Chef does not like this division of islands into several clans and wants to unite the islands by bringing all the territories under the rule of one single clan. Now, to this end, he can choose exactly one clan and give its warrior superpowers. Now, with the help of these superpowers, this clan's warriors will be able to capture the territories of other clans. On each day, the clan will capture every territory. Now, you need to make sure that you have read this carefully, that they can capture every territory that's adjacent to one already owned by them. Now we have to find the least amount of time, along with like we have to find the minimum amount of time required for one clan to capture all the clans, and also we need to find the clan which gives us this minimum time. So let me explain the problem statement using an example. Let's pick this example only. Let's pick both of these examples. So for the first one, see, for this one, if we take 2 as the chosen clan, like the second clan is chosen, then just let me make it a little bigger. See, if the second clan is chosen, then on the first day, since this is one of their territories, they can capture this and this, right, on the first day. And since this is their territory, they can capture this also. This is already their territory, they can capture this also. On the second day, now this is already their territory, so they'll be able to capture this also. So basically in 2 days, if you choose the second clan, you'll be able to capture all the clans in 2 days, right? So that's why the answer for the first test case is 2 and 2. Is it making sense? Yes, no? Is it making sense? Okay, it's making sense. So similarly for this, if you choose 4 as your answer, it will take you 4 days. It will take you 3 days. Why 3 days? Basically, on first day you'll capture this, on second this, on third this. If you chose 3 as your clan, you will get again 2 as your minimum days. So that's why the answer for the second test case is 2 and 3. 2 is the minimum number of days, and 3 is the clan. Like basically, you'll have to output 3, 2. Like first you'll have to output the clan and then the minimum time required. Like yes, first you have to output the clan and then the minimum time required. So here we choose 3. On first day we'll capture these two, and on the next day we'll capture these two. So I hope the problem statement is clear. Now what we are doing here, see, if we have these are the clans, and basically the clan that we chose had the value here and a value here. So we have to capture all of these, and these. So all the values that are before this, they will be captured only because of this. So let's say these will come like this, only X. Let's say the all the values that are after the last clan will also take 1 day to capture each. So Z here. Now all the territories that are in between two of these territories, like let's say they were Y. So what do you think? How many days are required to capture these? What is the number of days? Basically you have done y divided by 2 seal, right? So that's why you have written 2 because of this 3. You have to 3 divided by 2 and you have taken seal, right? This is what you have done. Okay, so my answer for each case is nothing but maximum of x or y by 2 or z. So this is that you have to do, like for every clan, find this value, like what is the minimum time, like this, and out of these, all of these possibilities, pick out the answer which is most suitable. Is it clear? Okay, perfect. So let me show you the implementation. So in this, first I have taken array A as input. Then these are just two helper vectors or arrays. Then the gap between this and the last clan is this much. And if there was, like, this is not the first occurrence of this AIth clan, then I have just taken seal. This is seal of gap by 2. So if this is indeed the first occurrence, then I won't take this division by 2 and seal. So required of A of I is nothing but maximum of this thing. Now I'm updating my last of A of I. So this is just simple iteration and finding that thing. Then like I said, for every, you have to take these territories also which are occurring here. That is after the last occurrence of the AIth clan. So for that, we are just iterating in reverse direction. So doing the same thing, like you can either do it like this, or what we can do, if this is not the last iteration, like if last of I is not equals to -1, then this simply means that what does this mean if last of I is not equals to -1? What was last of A of I? Last of A of I was simply that what is the last after this loop has terminated. Last of A of I will give me the last position at which AIth clan was there. So if last of I is not equals to -1, this simply means that I have some valid position for it. Otherwise, if it is -1, then it simply means that it is not present in my array. That clan is not present in my array. So this is just a simple check that if this ith clan is present in my array A, then required of I for the ith clan, it will be maximum of required I, and this is nothing but the clans or the territories that occur after the last occurrence of the ith clan. So these are those z value, this thing. We have already taken care of this and this, right? So now taking care of z. Now after this, I can always do this thing. If required of I is more than 0, more than or equals to 0. See, if required of I is equals to -1, it simply means that the ith clan is not present in my array because I have initialized my array with -1. But if required of I is more than equals to 0 and answer is more than required, so my answer will be required of I. And who is this, like, which is this clan? So who is storing the clan? So ith clan. So finally I can print my who and answer. So is it clear? Okay, perfect. So let's go to the next problem. So now in this problem, we are given that a mother bought a set of n toys for her two kids, Alice and Bob, and she has already decided which toys goes to whom. Now, however, when she has forgotten the monetary values of these toys and she only remembers that she ordered the toys in ascending order of their values. Now, the price are always non-negative, and a distribution is said to be fair when no matter what the actual values were, the difference between the values of the toys that Alice got and the toys that Bob got does not exceed the maximum value of any toy. So formally, like, let Vi be the value of the ith toy, and S is the binary string that tells us which toy is received by Bob and which toy is received by Alice. Now then the distribution represented by S is said to be fair if for all possible values of V such that it is in this fashion, this condition is satisfied. So I'll show this in a moment, but we have to print yes if the distribution is fair, otherwise no. So let me take an example. Let's just copy this. First of all, what does this problem mean? I'll have to copy it again. So see, the first test case is this, right? So this simply means that this was received by which one, Alice or Bob? So one means that the toy is received, is given to Alice, right? And 0 means that it is given to Bob. So this simply means that Alice received one of the toys, and whatever the value is, let's say it is Vn or V1. So Bob received nothing, so 0. So Vn minus 0 is only Vn, right? Vn only. So the difference is Vn only. The total value of toys received by Alice subtracted total value of toys received by Bob and taking the absolute difference. So it is Vn also. So this is a valid distribution. This is a fair distribution. Why? Because the final value that we get, the difference, is less than or equals to, is not more than the value of the most valued toy. So if this would have been more than Vn, then this would have been a unfair distribution. Look at this case. So in this case, Bob gets V0, or let's say V1 and V2, right? This is the value. And Alice gets nothing, so -0. So the absolute difference is V1 plus V2. So this is definitely more than V2. That is Vn, right? Like whatever the value of Vn is, Bob will always get, like there is at least one way in which Bob will get toys in which the value is more than v2 or vn. So in that case, the distribution is not fair. Like let's suppose if this is any positive number, whatever this value is, the total will be always more than this value itself, right? So that's why the distribution is not fair. Is it clear? So we have to find whether the distribution will always be fair or if it won't be always fair. So when won't be the distribution fair? See, if let's say at last I'll write that Alice got this gift or this toy was received by Alice. Now tell me one thing. If I have another one beside this, it's always possible for me to have this as any positive number. And anyway, this is anything like this is Vn. And after this, like whatever this is, maybe it's always everything zero. Like these all toys were received by Alice, like not Alice, but by Bob. This is any positive number. So these two were received by Alice and these were received by Bob. But I'm saying this is still not a valid or a fair distribution. Why? Because all for the toys received by Bob, if I fix their value to be zero and this is any positive value, maybe +1, and this is Vn simple. So the difference will be Vn, the value of all the toys received by Alice is Vn +1, and the value of toys received by Bob is 0. So the absolute difference will be only Vn +1 only, which is more than Vn. So if the last two characters are same, this would have been same if there was 0. I can always make the value of all the remaining toys 0, and I'll always get the difference between the toys value more than Vn. So in this case, the answer is always no. Are you getting my point? I'm talking about only the last two characters. If they are same, then it is not a fair distribution. Now, let's continue this further. If I have this one, this is 0. I have made sure that these two are not same. Going further, see if this is same, this is, then I should look at these two characters, the next two characters. Why? Because if again those two are same, I can always I can again say that this is not a fair distribution. Why? Because this was Vn. I'll also make this as Vn. Now again I can ignore this part now. So this is same as the earlier problem, right? Make this as Vn, make this as 1, and everything is 0 here. So now Bob is getting a value of Vn +1 and Alice is getting 0 because this is getting received by both. So we'll ignore this. So again, the difference is more than Vn, which is Vn +1. Are you getting my point? So first we were looking at the last two characters. If those were same, the answer was no. Then we looked at again the next two characters from last. If those are same, the answer is again no. Again, like this would have been same if the characters were 1-1. Is it clear? Yes, no. And if we keep continuing this, like we cannot have same characters anywhere in the string. We can also do this in using a different ideology, but this also works. Are you getting my point? Yes, no. Like this is easy, a little easier to understand, but like there is no point in going through different solution. But okay, it's clear. So let me have one more iteration. So assuming that okay, these two characters were not same, and the next were also not same. So let's say we had again, and we have the same characters here. So this again, this is not a valid permutation because I'll make all of these Vn. This is Vn, this is Vn. So this gets cancelled. Both of them are getting Vn value twice. Again, both are Vn. So let's ignore up till this part. Now this is Vn, this is Vn, this is maybe 1, the value of this toy, and all the other are having value 0. So again, Li's got toys of value Vn plus 1. I can assume it to be Vn plus 1. I'm ignoring these because this is same for both. And Bob received 0 value toys. So the difference is at least Vn plus 1. Now it is more than Vn. So that's why it is not a valid permutation. And I can keep on doing this. If I get, like, I'll keep on checking 2 characters at a time. If at any point I find that the 2 characters are same, then answer is no. Otherwise the answer is yes. So let me show you the implementation. So this is the implementation. Flag is 0 if the permutation is fair, otherwise it is not fair. So starting from the last index, I'll keep checking the last 2 characters and I'll keep decreasing my I by 2. Finally, if f is 1, that means that it is not a valid or a fair distribution. Why? Because I have found, at least like when I was looking two characters at a time from last, I found 2 characters to be same, 2 adjacent characters to be same. So that's why this is no, otherwise it is yes. Is it clear? Like if you have any doubt, you can ask me. If you're not able to connect it, or if you're having a like hard time in imagining how I got to this part. Okay, you have understood it. Perfect. So let's go to the next problem. So going to the next problem, we have that we are given an n-digit integer with some unknown digits marked with a question mark, and we have to count the number of ways to fill in each of these question marks with a digit between 0 to 9 such that the resulting integer is a positive and a multiple of 9. Now the integer cannot have leading zeros, and 2 ways are different if some question mark, that is the chosen digit, is different. Now this is very important. Even though the number of ways can be very large, we should print the complete number. Like we don't have any modulo to take. So first of all, let's suppose we had some modulo, then we could have solved this problem using dynamic programming. How? Like we would have made a, maybe, like you don't need to actually make a n cross 10 table, but we could have made an n cross 10 table, and dp of ij would have given us number of ways to get j as the sum of digits up till I. Like basically this would have meant how many ways there are, if this is my I, how many ways there are to fill question marks in the prefix of this part, such that if you're looking at only this part, you will get j as the sum of your digits modulo 9. Like not, like j is basically sum of digits modulo 9. Just give me a second. Is it? Like j is nothing but j is actually sum modulo 9. So instead of 10, you can also make like 9, n cross 9 dp array. But I won't get into the dp solution because it is not required. But I'm just saying that if we would have got a mod, this is how would we have approached it, or this is one of the possible ways to approach this problem. So like first of all, you don't have any doubt in this, right? Like the transitions would have been really simple and everything. Like this is just one of the ways to do this. But the thing is, we don't actually have a modulo value, and like during transition, we could have used that modulo. Now the thing is, if we don't have a modulo, we need to print an answer that is very big, right? So first of all, the thing that should come to our mind is that answer, like we should be able to print it character by character. Because if we have to print 10 to the number which has having a length 10 to the power 5 maybe, then it will be very hard for us to, like, we cannot store any number more than 10 to the power 18 or maybe 10 to the power 19, something like this, right? We cannot store a number more than this. So, and we don't have a modulo. So that's why if you have to print a number which is having a length of 10 to the power 5, to try to understand, like, this is not 10 to the power 5. It's a very, very, very big number. It's 10 to the power 10 to the power 5. It is having these many digits. So if you have to print this number, we have to print it character by character. Now, how to actually solve this problem? So let's try to see what happens if there are some question marks, right? So what if there's a question mark at the first place and then there are some numbers? What happens? Like, there are some question marks somewhere in between also, but there's a question mark at the starting point. So first of all, coming to back to the basics, why I am actually doing this, like, this should have been cleared at that point, but anyway, why I'm doing this? Because in DP solution also, I don't actually want, I, I always want what is at this point, what is the number of ways to achieve J, which is nothing but sum modulo 9. Like, because finally a number is said to be divisible by 9 if the sum of its digits is divisible by 9. So finally my answer in this DP array would have been DP of n comma 0. Why? Number of ways such that I could have filled all the question marks in this range in the prefix of n, that is the complete array, with some numbers such that the final sum modulo 9 is 0. So if sum modulo 9 is 0, then the number is divisible by 9. So that's why I was doing this thing. Now doing the same thing here, if I want the final sum to be divisible by, so what is the possibility for this thing? The possibility is either they will be 1, 2, 3 or 9, right? I cannot have anything other than these. Why? Like, there is also one more thing, 0, but I cannot have a 0 at the first place. Why? Because it's not allowed. So tell me one thing, if looking at this thing, first of all, how many number of ways there are to fill these? If there are total, let's say, k number of question marks in your number or in your string that you get in input, so there is this one question mark, there are these k minus 1 question marks remaining. So total number of ways to replace these question marks with some digits is 10 to the power k minus 1. So now I have a complete number written down here, right? Yes, no? Is it making sense? I have a complete number. These are the total number of ways to replace these k minus 1 question marks. And after this, I will have a complete number written here. So can I not find the sum of it? And final, let's call this as sum dash. Finally, I want my sum to be divisible by 9. And what is my sum? My sum is nothing but digit at 0 place plus sum dash. So this should be divisible by 9. Now, there is only one possibility for this D0, because modulo 9, if I have digit 1, I will get modulo as 1. If I have digit as 2, I'll get modulo as 2. If I have digit as 3, I'll get modulo as 3. If I have digit as 9, I'll get modulo as 0. So basically, these are from 0 to 8. So every digit will give me a value, a modulo value, modulo under 9, which is unique. So that's why for a value for each of these sums value, this digit is fixed. So if my first index or first position is having a question marks, my answer is 10 to the power k minus 1, where k is the total number of question marks. Is it clear? No, you don't actually have to check for every digit, every possibility for the first. See, like I said, if the first one is having a question mark, you don't actually have to check for everything, 1, 2, all the way up till 9. You just have to find 10 to the power k minus 1. Because for each of these, let's say you get this thing, 1, 2, 4, question mark, question mark. So right now, let's say I replace these two question marks with 2 and 3. So my number became 1, 2, 4, 2, 3. So what is the sum of this? 1 plus 2, 3, plus 4, 7, 8, 9, 10, 11, 12. Right? Is it correct? Yes, it is correct. So what is 12 modulo 9? It is 3, right? It is 3. So the sum of this part is 3. So what should be the number here? If the complete thing should be divisible by 9, it should be 6. So this digit is fixed. If these two digits are fixed, this is also fixed. If these two places are fixed, this will automatically get fixed. You have to keep 6 here if you want the complete number to be divisible by 9. So the number becomes 6, 1, 2, 4, 2, 3. So these two places were having a question mark, and this was also having a question mark. So this is the first place. If you fix these, this also gets fixed. So that's why if the first place is having a question mark, then the total number of ways is 10 to the power k minus 1. Just fix the remaining k minus 1 places. The first place will all automatically get fixed. Is it clear? Now, looking at other case, if the first place is not having a question mark, then how will we solve this? So, so looking at the same thing, first, let's solve the problem when the first place cannot have a 0. Like earlier, we solved this problem same, assuming the first place cannot have a 0. So let's solve the again using the same idea that the first place cannot have a 0. So we'll get 10 to the power k minus 1, right? Then let's, these are all the cases in which this first leftmost place is not having zeros. So let's make it 0. So now this is 0. Now this will be the leftmost place. So again, we'll have the same thing that this cannot be 0 and all the other places are 0. Like all the other places can be anything. Like this is not 0. All the other places can be anything. Fixed those, and then you'll get a fixed value for this thing. So the total number of ways for that will be k 10 to the power k minus 2, because earlier k minus 1 was this. Now k minus 2 is this. Fix these. So we'll keep doing like this, 10 to the power k minus 3 up till 10 to the power 0. Are you getting my point? Like first, I'll assume that this is not 0. So I'll get all these possible cases. Then I'll make this thing 0. Like this is fixed that this is 0 only. And then I'll make sure that this is not 0 and work for these. So I'll get these many cases. Is it making sense? Yes, no? Is it? Okay, it's clear. So in this case, the answer was 1 followed by k minus 1 zeros. In this case, the answer is simply 1 followed by k minus 1 ones. There is only one edge case. Can you tell me what? See, in each of these cases, I have first made sure that first of all, this was not 0. When this was 0, then I have made sure that this is not 0, right? When this was also 0, I have made sure that this is not 0, right? Because this is what I was solving here. I was making sure that this is not 0. And then these can be anything. So this was 10 to the power k minus 1. And whatever, I would have adjusted this digit accordingly. Instead of 0, I'm taking it as 9, right? So for this also, I have solved the same problem. So there is never a possibility that all of these question marks are changed into 0 only. But it should be possible when the remaining number of like the remaining digits is always like is already divisible by 9. If I'm having something like 9 9 9, so this thing is already divisible by 9. So I can replace all of these question marks with zeros. So if the sum of remaining digits is already divisible by 9, you need to add 1 to this. Why? Because this one is basically all the question marks can also be replaced by 0. Something like if you have only question marks. So you or like you only have question marks and the first one is divisible by 9. Or the remaining digits are divisible by 9, maybe something like 4 or 5. So in this, you can check this thing. Like this is should be divisible by 9. This thing should be divisible by 9. So basically, I'm adding one case in which every question mark is 0 only. So in that case, you have to add 1. So in that case, your answer will be 1, 1, 1, 1, 1, and last digit will be 2. Otherwise, your answer will be this. Otherwise, if the first digit is question mark, then your answer will be 1 followed by k minus 1 zeros. Is it clear? Is it clear? Yes, no, or is there any doubt? Okay, so let me show you the implementation. So first, I have taken string n and s as input. Then I have taken, this is the total of all the digits, like the sum of all the digits which are present in the array or present in the number. And these are the digits which are missing, like k. Instead of k, I have taken it as rem, like the remaining positions which I have to fill from my side. So if remaining is first of all 1, like instead of having this as the corner case, like you can adjust it here also, but I have taken it separately. If there is only one place which I have to fill, and that thing is not at the start, and total is divisible by 9, so I'll print 2. Otherwise, these are the general cases. So first I'm printing 1, and for k minus 1 places, I'll be printing this will simply become 0, complete thing, if s of 0 is equals to question mark. First of all, if s of 0, if the first character is question mark, this thing will become 1, and this thing will become 0. Why? Because of this thing, right? So this thing will become complete 0, this thing will become 1. So 1 minus 1 is 0. So k minus 1 or rem minus 1, zeros will be printed after 1. Otherwise, if s of 0 is a question, like if this is not a question mark, then this will remain 1, and it will keep on printing 1 till this condition becomes true. When this condition will become true? When this is the last character, total is divisible by 9, and the first character was not a question mark. So in that case, the last character will become 2, and other than that, every other will be 1 only. So this handles all the cases, that 1 followed by k minus 1 zeros, 1 followed by k minus 1 ones, or 1 followed by first some ones, and then at the last there is a 2. Is it clear? You can write this in a much better way instead of like having everything jumbled at once. So anyway, it is clear. So thanks for joining, and bye bye.